When I want to learn something new, I'll dive right in and start hacking something together using my intuition and Stack Overflow. I want to invest a couple of hours getting a feel for how things work without worrying too much about the right way to do it. So if all I want to do is build an Android app that will automatically turn on my internet-connected lights when I get close to my house, do I really need to use fragments, services, and intent receivers? For me, step one is getting something to work, a proof of concept that what I want to do is even possible. It's throwaway code that generally no one will ever see, but it'll get me excited enough to sit down and invest the time required to build something real. Developing real apps for mobile is complicated, so as a developer advocate, I worry that we spend so much time encouraging beginners to develop the right way that folks like me will get frustrated before they experience the thrill of getting something cool to work. So, before looking at why we can't simply do everything within a single activity, let's go ahead and build a prototype that does exactly that. So we've got the main activity. This is going to be our main form. We've got nothing in here at the moment. So this is our base layout. We have text hello world. So we can keep this text view because this is where we're going to stick our location results so that we can see what happens as we're getting location updates. We want to give it an ID, so we're going to call this location text. So now we're able to get access to it, and we can change the text. We don't want that to be with hello world. We want this to show our location, so I'm just going to set this to none received. So let's find a button. Drag that on here. I'm going to put it underneath. We'll change the text here to location on. And we're going to grab another button. Put it next to the first button. I'm going to call this one location off. In fact, I'm going to drop it underneath. So now we have a really simple layout which is going to let us turn the location manager on and off. So we're going to need to make sure both of these buttons have IDs as well so that we can get access to them. And ID is button on, and this one is going to be button off. And we're going to change our text ID as well so that it's consistent with the others. This will be text edit location. Now we're going to flick back to the main activity. And we know that we have an off button. And we have an edit text. And we're also going to want a location manager, which is what we're going to use to get location updates. Location manager. And then we're going to want to use the on button to enable our location updates. So we'll assign a new on-click listener and request location updates from there using the location manager. And then we want to have something to turn off the location listener, so do the same thing for the off button. Alright, well, first we know this is a text view, not an edit text. Let's go ahead and create these values. Min time is going to be 10 seconds. Our min distance, 1 meter. Now for our provider, we're going to use the location manager again. Get best provider criteria, one which is enabled. And in fact, we're going to go ahead and move that in here. Really the only thing that matters here is whether it's coarse or fine, where coarse is going to give you a better battery life and fine is going to give you higher accuracy. Really you're just choosing between using the GPS or using the Wi-Fi. Alright, so now all we need is a listener. We could do that inline as well, but we're going to do that out here. So at this point we're going to need to have our text view have a scope that we can actually access here. So let's bring it outside of our onCreate. And on location changed, we're going to set our location text. Eventually we're going to want to update this. For now, we just want to see it updating as the location changes come in. If our location provider is disabled, we'll want to update the text to say as much. So, now in the real world, you're going to want to do something there, which is most likely find a different location provider to use. This is usually if the GPS got turned off for some reason. But again, for our purposes, we just want to be able to see what is happening. So if we come down here, we can see something is underlined in red. So what's going on here? We need to get the right access permissions to be able to get fine location. So let's do that. Add permissions for fine location. Alright, so what we're seeing here is actually the new permission model for M, where we need to ask for that fine location at the time at which it's requested. Let's make this a little bit more readable. Alright, so this is going to check to make sure we have permission, whether it be fine or coarse, depending on what kind of activity provider we are requesting. In this case it's going to be fine, but we may change that, and this is going to handle both of those cases. And what it's suggesting we do here is, if that isn't the case, that we call request permissions. And that'll then pop up a dialog asking the user if they are going to allow us to use it. So we're going to need to override this method if the user does allow us the permission to use a location. Now here we're going to want to enable our location updates. Which of course doesn't yet exist, so let's put that in here as well. Which means we're going to want to call it here. Now of course that means we need to move our location manager to a different scope. Let's put him up here as well. And we're going to take their advice and we're going to call request permission here. And we're going to move this down here as well. Min time, min distance needs to get moved also. This gets us far enough that we're able to see whether or not our location call works. So why don't we fire up the emulator and see what that looks like. Let's start by turning location on. So this is the permission. We're going to say allow. So let's go with location, and let's send it. Alright, so you can see the updates coming through there. Turn location off, and nothing happens. Now, of course, for our testing, we really like to see all of these instantly. So why don't we go back into our code and change the update rates. So this should get us all updates all the time. So now I'm going to tidy up a little bit and move a few things around. My real goal here is just to separate all the boilerplate code like listeners, click handlers, and permission checks from my app and business logic. This separation is also going to make it easier for me later when I need to move and refactor it and pull it out of this monolithic activity into the appropriate services and intent receivers. Ideally, I want to be able to see all the code I'm going to be adjusting and changing regularly on the same screen. Now we know the next thing which we need to do. So we know that we're going to want to react to the location changing, because the ultimate goal here is, once we get within a certain distance of our house, is to turn on the lights. So we're going to need at least one more method, which is going to turn on the lights. And we're going to call that here. So okay, so we need to find out whether we are within a set distance. So we'll probably want to have ways to set all of that in our UI. But for now, let's just go and make some statics. So we're going to need to know how far our current location is from our home location. So we can do that by saying location.distance2, and we can say here our home location, which means we're going to need to have a home location. So let's do that, let's cheat, do that manually. Explicitly set the latitude and longitude. Right, neither of these exist. Oops, neither of these exist. I'm going to interrupt myself here to point something out. You may have noticed that I'm setting the longitude twice and never setting the latitude. That's something I didn't notice at the time, and it's going to cause me problems later. I'm going to go with Google's home location, which I will grab. So we have a distance, which is the distance from the current location to the home location. If it's less than the turn on distance, which we've set to 10 meters, then toggle the lights on, which is happening down here. So we know that we're going to want to turn the lights on and off, and that this is going to be a command over the interwebs. We can't actually, or we're not allowed to access the internet on the main thread, so we're going to have to move it into a background thread. So we're going to do that by creating an async task, which creates some simple handlers for us to make this life a little bit easier. Again, like I said, not the right approach to this, much better ways using services, but this is an easy way for us to get started. Async task lets you move a task into the background, optionally reporting progress while it's being executed, and then synchronizing with the UI thread when that task is complete. We can choose to pass parameters and optionally return a value from the background task. Here we're going to use void to specify that we don't want to use any parameters or return any values. I don't have an API or a REST call to make that happen, but let's have a look. We want to be able to have a way of finding out that this is actually happening. Why don't we return a Boolean? Alright, so now we're going to get a return from the background task telling us whether we've turned the lights on or off. We're going to want to override onPostExecute, which is what gets called once the background task has finished. And here we get the Boolean returned to us. And we'll use a toast here because this is now synchronized to the UI thread. So the onPostExecute is synchronized to your UI thread, so we can do things like this. Alright, let's have a look at what that looks like on the emulator. So why don't we just go ahead and paste in the specific lat and long for home. Now what we're expecting to happen is I hit send and we should get a toast that tells us that we have turned the lights on. That blank look corresponds to something on the inside that looks a lot like this. Notice that the lat long value has changed, but I was expecting a toast and there isn't one. You and I know that's because I set the home location longitude to its latitude and its latitude to 0. At the time, I didn't know if the problem was my asynchronous code, the toast, or something related to the distance from home calculation. I knew the lat long coming in was correct, so I decided to update the UI to show my current distance from home instead. That would be useful for debugging and give me a clue as to what was going wrong. So now that we have all of this, rather than displaying the latitude, longitude, which doesn't really mean anything, I mean, we know what that does now. So what we're going to do instead is update our text string to show the distance so we can see as we're getting closer, because that's really the critical part that we want to have now. Okay, so we're getting a distance now. Perfect. Eventually I tried plugging in the values for my home location at the Googleplex, and the distance result is not what I expected. So now I know the problem is the distance calculation. I spent several minutes going down some blind alleys. I'm pretty convinced I'm transposing lats and longs somewhere, but eventually I see what's right in front of me. Alright, so you can see I've set both latitude and longitude to the same value. Now we are much closer to our house. In fact, less than a meter away, which you'd hope, given that it's the right value. But wait, it's that face again. I know my distance is right, but there's still no toast. Now I'm annoyed. What the f... I set some breakpoints and stepped through this a couple of times. Looks like I'm getting the right values at the right times, the right code is getting executed, but still no toast. Maybe I can't call a toast from within an async task, maybe I'm sending in the wrong context to the toast. Eventually, I decide to take a look at why the little red light bulb is highlighting my code, and of course, you're going to want to show your toast. Alright, so there you go. That all works as you would expect it to. So we've got an app that's a pretty reasonable proof of concept that it's at least possible to do what we want, automatically turn on our internet-connected lights when we get close to home. This screencast represents about 2 hours of real-time coding. Most of what's been trimmed is me thinking, or going down wrong alleys when debugging, waiting for emulators to spin up, or trying to remember which API calls I should be making. Now, if you're an experienced Android developer, you're probably getting ready to throw something through your screen right about now. And if you've done even a little Android training, you're either angry or confused, and rightly so. While this code will technically work, it does a lot more wrong than it does right, which is why you typically don't show people your throwaway prototype. As you can see from these red circles, each representing code that either doesn't belong in an activity or has been replaced with a new and better API, or both, not much of what we've written is going to be kept. And that's ignoring even basic things like how to handle activity lifecycle events and potentially leaking memory through our location listener and async task implementations. Now, turning this into a real app is where the complexity comes in. Later videos in the Pivotal series will dive into each of these issues in detail, but let's take a quick look at what a better structure might look like. For starters, in a lot of other platform paradigms, that main form is synonymous with the app itself. And that's not the case in Android. The only thing that should be in the activity is the UI. Anything else, like requesting and receiving location updates or making internet API calls, needs to be moved elsewhere. So a better architecture is to have an activity for the UI combined with services to provide tasks when the UI isn't visible, and an intent receiver to react to context changes even if the app isn't running. Ideally, this app will be almost entirely autonomous. You do need an UI to turn it on, to set a home location, and the rest will then be automatic. You don't need to use fragments here, but encapsulating that UI logic into fragments will make it easier to build out more complex UI navigation patterns later. Apps without visible activities get killed by the runtime, so if we want to get continuous location updates when another app is in the foreground, you'll need a service to keep it alive. Within that service, we can either trigger the constant location updates as we did in our prototype, or we can be more efficient and use the geofencing APIs available from Google Play services rather than constantly calculating the distance from home. Using that API, we may not even need this service. The light control API calls absolutely need to be in a service. All internet lookups need to be moved out of activities, and using a service will ensure it can complete before the app is killed. Finally, we want to move our location listener out of the activity and listen for location change intents from within its own intent receiver class, which will register in the manifest. We do this so that even if the app has been killed by the runtime, we will still receive location updates. The app will actually be started specifically so that it can receive these location change intents. And then they can start the lighting service if that's necessary. So after a couple of hours, we have a working prototype and the first pass of a more robust architecture, a good starting point to start hacking away in earnest. It's important to understand the right way to build apps, but that shouldn't get in the way of hacking and slashing your way to a proof of concept before you begin in earnest. If you found this interesting, keep an eye out for my new show, Pivotal, where I'll be screencasting the process of creating and upgrading a full location and context-based app using the best practices and patterns that I've started describing here.